Well, good afternoon, and welcome to the first lightning talk of the day. My name is Giles Heron. I'm a principal engineer at Cisco Systems, and today I'll be giving you an introduction to Media Service Mesh. So before I describe Media Service Mesh, I think it's worth discussing why we might need such a thing. And I'm going to start with an application taxonomy. So a friend of mine who did an MBA assures me that any problem can be reduced to a 2x2 matrix. So here we have a 2x2 matrix describing networks applications. So in one axis, you have whether an app is non-real-time or real-time. In the other axis, you have whether it is interactive, so typically request-response semantics, or streaming, so typically publish-subscribe semantics. So I think it's fair to say that service meshes today really focus on web applications, and those apps are in this top left corner here. Now, you could use a service mesh to interconnect the nodes of a message bus, but you'd probably just be transporting that traffic as TCP, so you'd be transporting the message bus rather than being the message bus. But where you might struggle with service mesh today is on the right-hand side. So real-time applications, and that's going to be our focus for media service mesh. Those apps could be interactive, such as online games, or they could be streaming apps, such as closed-circuit TV. Now, I called this a fuzzy application taxonomy. Why did I say fuzzy? Well, I would contend that these dividing lines between non-real-time and real-time and between interactive and streaming are actually quite fuzzy. So in terms of real time, I might be watching football on a streaming platform. It's live football, but it's not quite real time because it's using HTTP streaming. And so if, for example, a friend of mine is watching on cable and my team scores a goal, he might text me to say, wow, great goal. And I'm going to be annoyed because I haven't seen the goal yet, though maybe not as annoyed as I would be if the other team scored. However, even that supposedly real-time feed he's watching isn't quite real time. So those of you who, like me, are old enough to remember analog TV, will remember when the news would come on, and just before the news, you might see a clock counting up the seconds as it came up towards the hour. We don't have that anymore because the time taken to decrypt these MPEG digital streams is slightly non-deterministic, so they gave that up. However, if you're working in the TV studio that's producing that football stream, you're going to want it to be real time. So you might have a live camera feed coming in from the stadium. You'd be adding on at the top of the screen something to say, here's the score. At the bottom, you might have a strip that's showing news flashes or showing scores from other games. All of that's going to be put together live in real time before it's sent out. And those streams are typically uncompressed multi-gigabit streams. So this is very different from the web applications you have today. In the other dimension, of course, it's also fuzzy. So what would you call a multi-party video conference? Would you say it's interactive, or would you say it's just a set of unidirectional streams? I suspect truth lies somewhere in the middle. So there are three goals that I would identify for media service mesh. The first is simply to extend the benefits of service mesh to real-time apps. So those benefits are going to be things like very flexible load balancing, support for canary deployments, the ability to export metrics and statistics, the ability to do authentication and encryption from pod to pod. Now, all of those things are things that we'd like to hand off to the service mesh rather than handling our application. We also want support for interactive and streaming applications, and those have slightly different challenges. So interactive applications such as games, you very often see developers rolling their own protocols on top of UDP. The challenge there is that UDP itself is connectionless. It's just datagrams. There's no connection, there's no sequence numbers, so it's very hard to track connections, to detect packet loss, etc. What you do see, however, is some de facto standards for games. So as an example, I got this from the improbable.io website. So in their spatial OS protocol stack, they have two different UDP-based options. There's KCP and RACnet. They also, in fact, support TCP, and they have graphs on their website showing how much better the performance of these UDP options is than TCP, but then, in fact, KCP is slightly better than RACnet. Now, KCP is a newer protocol, and in fact, when you look at it, it feels like a really good match for service mesh, and that you have these three layers of reliable transport, erasure coding, and encryption. And these are all things you'd really want to hand off to your service mesh rather than handling them in your application. On the streaming side, most people use RTP, so at least there's a standard there for the layer above UDP. So here we have the WebRTC protocol stack, and you can see RTP, when in fact SRTP, so secure RTP, is a key part of that. On the left-hand side, you see all of the standard web stuff. So these three layers very much mapping to the three layers of routing in Istio, so TCP, TLS, and HTTP. But this whole right-hand side is things that can't be done today with a service mesh, running on top of UDP, as I say, particularly RTP-based traffic. Now, RTP, in fact, generally is run in conjunction with another protocol called RTCP that provides the sort of metadata feedback for RTP. RTP will run on an even port number. RTCP will run on the next highest port number, so it might be port 8000 and port 8001. However, those ports are very often dynamic, and so what we'll see is that RTP will run in conjunction with another protocol that might be SIP or it might be RTSP. That protocol will typically run over TCP. It will hand out those UDP port numbers used for RTP, and it will also use URIs or URLs, which, again, if we have a layer 7 proxy, we can now start to have routing rules for that traffic. So we can be routing it in a more fine-grained manner while at the same time watching those allocations of RTP, RTCP ports, and then wiring those into our data plane proxies. In the SIP world, people talk about pinholes a lot, so having these individual forwarding rules for the RTP traffic to get it through a firewall or whatever. Now, the other thing on the streaming side is very often, I mentioned earlier that we have publish-subscribe semantics. So very often what you'll see is one stream and then multiple clients consuming that stream. And so again, what we'd really like is for our media service mesh to handle that fan out so that the video server, for example, so taking an RTSP camera as an example, it can send one video feed, then the proxy can explode that out to multiple clients. Finally, we want to support 3 classes of applications. So we want to support applications that run in one cluster, apps that run across multiple clusters, but of course we also want to support internet apps that run from outside the cluster. So your client might be somebody at home, whether they're playing a game or whether they're on a video conference, and you want to tie them into a resource that runs in the cluster. I wanted to give a worked example of media service mesh in operation. The example here is a CCTV camera using RTSP proxies. I don't have time to show a demo of that today, but there'll be a link to that on the next slide. So the first thing that a client does when it talks to an RTSP server is it asks the server what options it supports, and we'll satisfy that locally from the proxy in this case. More importantly, the next message asks the server to describe the piece of media. Now, in this case, the proxy doesn't even know where that media is, far less what it comprises. So it will first have to find out where it is, and it will use the Kubernetes control plane and DNS to do that. And now it will know that it can send towards this endpoint address here. And so it will go to the remote proxy through to the camera, and that will flow back. And now the describe message will have all the streams within that media. And so now the client will send a setup for each of those streams with a separate stream ID. And what you can see is it's put its own ports on there. This is because it's running over RTP in this case. So there'll be a port for RTP and a port for RTCP. If it were to run over TCP, there'll be no need for port numbers. This example is all RTP based, but TCP can in fact be useful when we have clients connecting in from home, etc. That all works on the same proxy, and the proxy can mix and match between the two. But in this case with RTP, what we then see is the camera's response, and now it has its own port numbers as well as the client port numbers. One thing you need to remember here though is that in Kubernetes, there's a lot of address translation going on, so those port numbers are being changed. Now the nice thing here is that we can modify what we send, and we can also program mappings as those pinholes in the RTP proxy. Now that RTP proxy could be, as in my demo, the same piece of code as the RTSP proxy, or it could be separate, as shown here, and that's not really important. But the key thing is that those pinholes are set up. So finally, the client can issue a play command. That play command will flow through to the camera, and then the camera will start sending the media stream. Now, when another client connects, in fact, we don't need to connect all the way to the camera. It's a live stream that the camera is already streaming through the proxy. So now we'll just communicate with the proxies, we'll set up the pinholes, and finally the media will get played out from the proxies. I wanted to finish with a call to action. So my email address is there, and please do send me feedback, whether good, bad, or indifferent. There's also a link to a blog post. I'll put a link there through to the recording of the demo, so you can see that. But really, and ultimately, my goal for all this is for it to become an open source project and to have a community around it. So do please contact me, and please let's all start building media service mesh. So thank you for your time, and do enjoy the rest of the day.